Hello, in this video we're going to talk about the method of Lagrange multipliers. So to find the max and min values of f of x, y, z subject to a constraint g of x, y, z equals k, assuming extreme values exist and the gradient of g is not 0 on the surface g of x, y, z equals k, here are the two steps you need to do. Step 1. Find all values of x, y, z, and lambda such that the gradient of f of x, y, z equals lambda times the gradient of g of x, y, z. Okay, so that's one equation you need to work with. And also g of x, y, z equals k. All right, so you want to find all values of x, y, z, and lambda that satisfy both of those equations. Step 2. Evaluate f at all points x, y, z that result from step 1. The largest of these values is the max value of f, subject to the constraint, and the smallest of these values is the min value of f, subject to the constraint. Alright, so in the next video I'm going to show you a few examples on how to work through the computations. But right now I'd like to give you a visualization so you have an intuitive understanding of what these Lagrange multipliers are really doing, and more importantly, what are we trying to find? What are we talking about with f, and what does this constraint function g look like? To do that, I want to hop over to the ebook. Okay, so here's a nice visualization of what's going on. We have our multivariable function, and that is graphed with the surface here. Okay, and down in the xy plane we have our constraint function. So in this particular problem the constraint is x squared plus y squared equals 1. And if you take each of the little points on that circle, let's say you take that point right here, this is 0, 1, x is 0, y equals 1. If you take that point and you apply the function to it, you'll get the corresponding z coordinate, and so you get a point in x, y, z coordinates, and that is up here on the surface. And if you do that for all the points on the constraint down here, what you will get is you will get the constraint mapped up onto the surface of this multivariable function. And so the idea is we're looking for where does the function achieve a maximum or maybe a minimum subject to the constraint. So I'm looking for the highest point of this red curve or the lowest point on this red curve. Okay, so this is the constraint mapped onto the surface of the function. So what we're looking for with these Lagrange multipliers, we're looking for the max or the min of f subject to the constraint. So I'm looking for this red line, where does it achieve a maximum or minimum? So it's kind of like, you are a person and you might put a belt on your pants, and where does your belt, like this red curve, where does it sit highest and where does it sit lowest? That's the idea.